Life cycle assessment is a process for assessing the environmental impact of a technology or a product. It was named by Time magazine as one of the important ideas that's changing the world back in 2009, and it is becoming increasingly used and increasingly important. On its face, it seems like a very simple thing. After defining the goal and the scope of the process, the researchers have to assess what are the individual elements of the product that are going to impact on the environment, and then they have to think about what is the actual impact of each of those elements. Sounds very simple. However, a whole series of problems arises and complications in trying to actually implement a life cycle assessment. How do you actually decide what is this partitioning of the product that you're going to do? What are the elements that are relevant? Do you assume that the product is being produced on a large scale or simply on a small scale? How do you come to an agreed measurement of the impact of each of the elements that are being assessed? Now, so it's through working through these problems that people doing life cycle assessments are starting to get sensible answers to questions like which kind of coffee cup is going to have greater or less environmental impact, which way of getting to work will have greater or lesser environmental impact. As it's developed, people have become increasingly aware that there seem to be values being appealed to across the process of doing a life cycle assessment. For example, how do you think about uncertainty and risk in the future and assess impacts upon future generations? What kind of counterfactuals are you prepared to countenance with regard to vastly different ways of doing production? How do you weight the different impacts that might occur? How do you compare, for example, impact upon the ozone and impact upon eutrophication? Some have argued that since there are these and other values at play when people are doing life cycle assessments, that it's not just for technologists to be doing it, but that stakeholders more broadly should be consulted. And furthermore, the life cycle assessment should take place further up front and throughout the process of innovation, rather than leaving it right to the end when often the technology will be locked in. And furthermore, that technologists should be cognizant of the fact that they are appealing to values and be aware that these might be things they might be challenged on and will need to defend. All of this is relevant to the interview that I'm introducing now, which is with Associate Professor Stuart Coles of Warwick Manufacturing Group, who is going to talk about the project called Bisigodos, which was a project that found ways to produce useful products from algal oils that would normally be made using petrochemical products.
Well, the Bisigodos project was designed to add value to algae bioproducts, specifically proteins, adhesives, polymer coatings, trying to make all of those in a slightly more sustainable and environmentally friendly way. Well, the idea behind the sustainability is that we're using algae as a feedstock rather than petrochemical-based sources. So looking at ways in which natural materials can be used in a renewable way rather than using depleting feedstocks from crude oil. The algae is grown in photobioreactors. In particular, in this project, it was a partner company in Alicante that were growing the algae. They've got quite large industrial-sized facilities that were able to process at scale and grow the algae there. But essentially, all you need is some kind of reactor, either a pond or a dedicated cylindrical tank, and a bit of sunlight and some water. You need to add some carbon dioxide as well, and that typically you can source that from anywhere, but in this particular project, one of the nice things about the work here was that the carbon dioxide was sourced from a local cement works. So instead of the cement works producing CO2 and sending it off into the atmosphere, it was piped into the photobioreactors and used to grow the algae that way. So that gave us an extra additional environmental benefit. Some of the products that were made from the Bisigodos products included polymer coatings for coil-coated steel and aluminium. It also included some polymer materials themselves, looking at additives for packaging. We also looked at making polymers for adhesives and also protein feedstocks that came from some of the wet algae biomass. In terms of what was good, The proteins were able to be produced in a particularly clean manner, and we were able to do these quite efficiently. But some of the products, like the adhesives, proved to be problematic, not necessarily because of the technical problems, but some other issues that were associated with the project. These issues, particularly with this product, were that the adhesive that was made from the algae oil was coloured green. The company wanted a transparent adhesive because it allowed people to see into their products. Often people, when you go shopping, you like to see into the packaging. You want to know what food you're buying, and that's a desirable quality of the adhesive, so that it allows people to get that visual appearance of the food. The adhesive that we made, it was green in colour, quite a dark green initially, and that wasn't transparent at all, very opaque material. So it was something that was required to be changed based on discussions that was had between ourselves and the partner consortium. Had we been able to keep it as the colour it was, then obviously there's then no environmental changes in terms of the process. But because we had to move from a green material to a transparent material, this obviously incurred extra processing costs, and it incurred extra environmental costs as well. Some of the materials that were involved, there's extra solvents that we used, and also extra decolorizing agents such as charcoal. Both of these have actually quite negative environmental impacts when you look at life cycle assessment of the materials. So that contributed in a negative way to the overall environmental profile of this particular product. In terms of social impacts of any of the products that were produced by our project, the social impact is relatively minimal because we're not trying to develop products that are new. We're trying to replace products that are already existing in the marketplace. So these are products that are already socially accepted. They're already purchased on a daily, weekly, monthly basis, depending on sort of the fast-moving nature of the product. So from a social perspective, there wasn't really a change in the product side. In terms of ethical issues, maybe some of the ethical issues around how the algae were grown, in terms of location and potential contamination of the local environment was one issue that we had to look at, and also as well some of the ethical issues in terms of health and safety, improving the toxicity of some of the materials that were being produced, and which, whilst toxicity is an environmental, obviously on the environmental benefit, also it has an issue for handlers and manufacturers because their workforces become exposed to toxic chemicals, and you want to reduce that where possible. In terms of how we address some of these ethical, social, environmental, economic issues within the project, we had to scope out, as part of the application stage, some of the tasks that we would do in order to receive the funding from the European Union. This included conducting a life cycle assessment to establish the environmental benefits of the project. We also conducted life cycle costing to establish the economic benefits of the project. There was a discussion around some of the ethical issues around the location of the algae bioreactors, but this was largely dominated by the location of one of our project partners and the proximity to their factory and also to the cement works. In terms of where the project has developed to, it's really now got to the point where it's at technology readiness level 6. That's kind of the point where we as a university step back and hand over the products to the commercial side.